and that's not really that important right now to us. We have N, L, M sub L, M sub S. And more or less, what they are they get more specific as we go. I showed this, oh shoot, I should have brought this up. Well, I will afterwards. So we have an energy level. If you're thinking about like a orbital diagram, which we will be again looking at later in the week, then on that orbital diagram, once you figure out the energy level, then what sub-level are you on? And a sub-level, is a little refresher, a sub-level is an S, a P, a D, or an F. Okay, that's what those are. And then I made a little arrow there if you'd like to write that right away. Unfortunately, these are called quantum numbers, and those are letters. And you can't have letters in something that's all about numbers. So we have to just assign some numbers. I think the biggest trick to this, just please remember and work on the fact that an S is a 0. It's not a 1. So if you label S as 0, then it just goes in order. S is 0, P is 1, D is 2, F is a 3. The next level then, once I'm on the sub-level, is where am I on that sub-level? And we're going to call those orbitals. We'll get those in a minute. And then what kind of spin do I have? Electrons have to kind of balance each other out. Okay, they have to even out, just like charges usually have to even themselves out. So, all right, lower left is the first number, and there's not a lot to write here, but on the left side here, N is always an energy level. So I just wrote in general that the electron's average distance from the nucleus increases the size of an orbital. Whoops, I think I put the comma in the wrong spot. The larger size of an orbital, that means it would be large. Oh boy, what was I writing there? I think I'm missing a word somewhere, but I was basically trying to say is as the electrons get further and further away, that means that my orbitals then are going to get larger. But that also means then larger orbitals, there's more energy then. Those electrons have more energy. They're further away. They've jumped higher. Or they're going to fall. Maybe not. Maybe there's nowhere to fall because there's electrons already filling up those other spots. So I have an image to show you. It's called the orbitron. I know I showed this a little bit last year. It sounds really fancy. It's really not. But we'll look at that in a second. And that's really all we needed to write for that one. The second level, second number, again, that's the sub-levels. And it's filling up the whole space. You, this year, are very much responsible for being able to recognize and understanding the 4 different shapes. You do not need to know all of them, but let me show a couple things. First, these are the S's. We have to recognize that an S is spherical. Okay, that's why there's always only one of them, which we'll get back to orbital diagrams and everything later. So I rewrote what's underneath there. That said like a 1s, a 2s, 3s. Notice they get larger. Okay, and that's the shape of an orbital, but that's just an S. P's. Every sublevel is gaining more energy. More energy is causing different kinds of patterns. More energy causes more erratic shapes. So this is an example of a p orbital. You can have your x, you can have your y, and you can have your z. Because of that, it can take up space in 3 dimensions. Okay, in 3 different locations. So that is the reason why we always have 3 p orbitals and only 1 s. An s is just one sphere, no matter how I turn it. It doesn't take up any new space. So you need to recognize that p's look like, they always call them dumbbells. It doesn't look like the dumbbells I use, when I move them around in a repetitive fashion. Okay. Number of possible shapes for an energy level is equal to n. So what does that mean? Is that first energy level only has 1 sublevel. Second energy level has a possibility of 2. So the second level has an S and a P. The third level has an S, a P, and a D. You do not need to know exactly what these all are. This is like dxy and dxz and dyz. This is dz squared. You don't need to know those specifics. You do need to know the specifics for the P, that it's x, y, and z, though. And then those are the F's. Notice they get more and more funky as we go. They definitely get more and more funky as we go. So do make a division line in between, please, like that you can see that. I wanted to show you one quick thing on that. Sorry, if you're still writing, we will come back. So this is called the orbitron. It's just a link, but I just wanted to show you this. Like, this is the S. There's just one, and now this is like 2s. It gets a little bit bigger. Now we have 2p, and maybe some of you have never seen this before, what I'm going to show you in a second. So then like the third level gains 3 sublevels. So then, and these are all artist renditions. Please don't think, whoa, like the 3p is so cool and springtime metallic. It's like, it is what it is. They're just artistic renditions. So then here would be the D. And now we have 5 different options because they get more complicated. Then you get to the 4th level, you gain another level. So now you have the S's and the P's and the D's. They're all getting a little bit bigger, a little bit further away. And now you got F's. And the F's, there's more lobes, okay? Every time it doubles in lobes. So you go from 1 lobe to 2 to 4 to 8 to 16 because you're gaining it's based on probability. Those balloons, if you want to call them that, or electron clouds are 90% of where electrons are existing. But this is what most people never see. You get to level 5, you're like, well, yeah, but it only goes F. In theory, there is another sublevel. So if this is what an F is, it's got to double in complexity. So this is what a G would look like. Why don't we have G's? Because in the ground state, we don't have enough electrons to get there. Like, we don't get past an F. But in theory, there should be G's. And maybe when they get jumped from the ground state to the excited level, maybe they go into a G. So if there's 7 F's, there should be 9 G's. And this is what it looks like. So it's really funky. Well, if you go to the 6th level, oh shoot, it's not on here. It used to have an H. There should be H's. There should be an H, but they don't have that. So this is a 6G that they just have on here. I think they used to have H's on here. And here's a 7G, which it should be bigger and further away from the nucleus. So it's kind of funky. But those are more of like theory and probability based on what they theorize, okay? Okay, we're almost done. All right. Last 2 items. So all that together, and I'm not quite there yet, but there's this thing, we can just put this in space. Layla, you will need to know this name. It's Pauli exclusion principle, and it really is actually quite straightforward in the fact that it just says that when we do have our quantum numbers, you can't have one electron has a specific 4 set of quantum numbers. Another electron will not have the exact same 4. You could have 3, but you can't have the same 4. It's like a street address. No house can have the exact same address. It's got to have something slightly different, or else all the mail would go to the same house. So to finish this up, once you finish writing that, it's the last part of our notes. Third quantum number, if you remember this or not, we're going to practice this, is that this is about the location on the sublevel itself. So it's like which orbital, and actually if you could write an arrow, and like these lines are actually orbitals, that's what we call them. Like, so there's 3 orbitals in a P. And what I would really like you to do is write this twice. In fact, at first, this is what we do. We say that the middle is 0, and maybe you're recalling some of this. Like I can't say, hey, the electron's on the 2nd line from the left. That doesn't ever work really well. So what we say is, oh, the middle is 0. And then we count to the negative side or the positive side. So if this was a D, you'd have 0 and then -1, -2, 0 plus 1 plus 2. If it was an F, it'd be 0 plus 1 plus 2 plus 3, and so on and so forth. We'll see how it all applies when we get into the final quantum numbers. Underneath, though, you could write it like this. When there is a P, technically, why are there 3? Because this orbital is P 2P sub X. So it's horizontal. And then this is 2P sub Y, which intersects that perpendicular, and then 2P sub Z, which again intersects that in a different direction perpendicular to it. That's technically what's happening. We usually just write it as 2P and then just put brackets. If you remember this, we put brackets right here. Okay? And then the final item, and then we're going to practice this on your worksheet that you got yesterday, Atomic Structure 1. The spin. You can think of it as an up and a down spin, but it's more realistic to think about it that there's like a clockwise and a counterclockwise. It's like tapping your head and doing your stomach. Spin where it has to counteract each other. Electrons are already both negative, so by nature they actually are trying to repel each other. So by having opposite spins, it allows them to at least inhabit the same orbital. And the pair must have opposite spins. We're going to assign it as plus 1/2 or just minus 1/2. That's all. Okay, so if you'd like, get out atomic structure 1. I believe there are some quantum numbers on the bottom there. I thought there were. Do I have an extra? Who's asking? Oh, didn't I hand that out yesterday? Oh, shoot! It's in the. I'll grab it. Find me later. I have one more in my room where I can grab it before the end of the class. Okay. Wait, Kevin, do you have the note sheet? Yeah, I got the note sheet. Okay. All right, I'm just going to do one of these. So you have an idea. We're going to do D, letter D. And of course, I'm covering that up now, just so you have an idea what and how this works. And once we start doing this, you're going to hopefully recall this very quickly. Okay, so we have to do 4 numbers. So this one's pointing, it's a little off, but it's pointing to that one right there. So first number is the energy level. Like we have to say like where, okay, we have all these electrons. First, it would be nice to say, hey, it's either here or here or here or here, like which level. So it's on the 3rd level. So I have a 3, and I put a comma. Then I'm on that level. Now is it on the S? Is it in the P? Is it in the D? Is it in the F? That's what I have to say now. So now I've gotten to here. Now I got to get into here. So what are we saying? That second one is about a sublevel. We assign S as a 0. So these would be 0s. These would be 1s. These would be 2s. F's would be 3s. So this would be 3, 2. Right? Because the 2 is the D. Now I'm on the D. Now what do you want to say? I'm on this orbital or that one or that one or that one or that one. So I have to say which one. You can't say it's the 4th one. So you assign the middle as a 0, and then this is plus and minus 1, plus and minus 2, so I'm on the plus 1. And you should put a plus. On that 3rd number, there should be a plus or a minus. Okay? And then the last one, it's either pointing up or pointing down, and we assign it as a plus or a minus 1/2 for the charge. The spin. So this is pointing to the one on the left. I know it looks like it's in the middle. So it's pointing up. So I say plus 1/2. And those are my quantum numbers.
What does the plus 1 represent?
Plus 1 is that it's on this one. Like this would be 0. Like if you guys want right now, you could write on here 0, plus 1, plus 2, minus 1, minus 2 to help you remember. Questions on that, because it's really important. Once you get it, it should click, but it does. You have to recognize and completely and fully understand what each number represents. I hope you do see and appreciate that each number gets more specific. Right? First we figure out the level, then where on the level, then where on that sublevel, and then where in that orbital. Am I the up or am I the down? Okay. So, lastly, if you want to look at your packet for a moment, please. I want to go over something with you. And then we are completed for the day. I gave you a schedule. Just kind of keep up with that, please. Open the page to 112, the packet. Please. All right. So, T.I., my favorite rapper. All right. On the top, just kind of, I think we have a little bit of space. T.I., what is T.I.? Besides a genius. Titanium? It's number 22. Please write 22E minus. And this is where you're going to have to kind of remember some of this stuff. So I'm going to go through this right now. We are going to jump down to the condensed. Do not do expanded. And by the way, if you flip the page, I've gotten rid of the expanded for the other ones. You only have to do this once. Okay? And it is very much you're welcome because it's a lot. All right, let's review this. This is going to take a couple minutes, and if you need to do more of this, you're going to get some practice on this sheet. There's a cheat pyramid that we learned, and if you remember this from a long time ago, that we did this thing, and we had to do arrows, right? Remember that? But then we learned that the periodic table is the cheat pyramid. So we learned like this is the S block, and this is the D, and these are the P's. So if this doesn't all click the first time, just try to take in as much as you can. We'll come back, I promise. So the first row is the first energy level. We only have an S. So this is, like, I got to get all the way to here. So this is 1s2. So I'm doing the second part. Is there an A and a B? Or a 2. So I'm doing the condensed. So it's 1s2 so far. Like, I just got to jump into this. I need 22 electrons. So then I get to here. I gotta plow through these blocks because I got to get to here. So this will go through all of this. So this is a 2s2. I jump over here. There's 6 of them. That should make sense because P's have 3 orbitals, which can fit 6 electrons. So this is 2p6. Jump down. This would be 3s2. 3p6. 4s2. Then this is where you got to try to remember this a little bit. This is the D block, okay? I will agree with this. It's D2, do we agree? Right, it's D2. And what number goes in front? A 3. Oh, wait, but it's on the 4th row. D's are 1 behind. Secondly, we also know that every energy level gains another sublevel. So that's another way to remember it, that there has to be a 3D because it's the 3rd level and the D is the next sublevel up. All right, that is the condensed. Is that the naming? I don't usually use that term. Let's go down to noble gas configuration. The noble gas configuration is actually a very friendly thing for us because all we do is we look at the row. We're in the 4th row, so you have to take the noble gas of the previous row. So that is automatically argon. And then what do? I include everything that is after argon. Well, if I've already done this, that's beautiful because that's the stuff on the next line, right? That's it. So I can just write 4s2, 3d2. A couple little side notes on that, by the way. If you end at argon, you cannot write argon. It has to be neon. You can't be like, sweet, brackets, AR, done. That is not how a noble gas configuration works. You always have to go to the previous line, no matter what. All right, so I'm going to get you started on this part. And I'm not going to do all of it. The expanded version is showing, and there's examples, and you can mimic these, okay? There's only one kind of S. So it's just 1s2, 2s2. But there are 3 P's. And these P's are 2p sub x, 2p sub y, 2p sub z. And how many are in each of those? It's like this is the p sub x, p sub y, p sub z. So there are 2 in each. I think you can see why I'm not making you do this a lot. You will not have to do this on the test, Layla, but you will have a better understanding by writing this out once, okay? So then you need to keep going. So right there, all of this is simply that, right? Like, wow, that's intense. Yeah, it's a lot. That's why, again, we're going to just do it once. I will give you a hint. This one will have a 3D something and a 3D something. Oh, no, there's already 2. Reminder, this is the last thing I'll say for today, is that you fill them. We'll practice this by the end of the week. You don't go up, down. You have to try to, it's called Hund's rule. You go up, up. So there's got to be 2 of these. So look at the previous reading and just find 2. It doesn't matter which 2, by the way. Well, how do I know which 2? Honestly, it doesn't have to be the first, like this doesn't have to be PX. We just usually do it because it's in alphabetical order. Like this could have been py. Like why is the first electron in a px? It doesn't have to be. Okay? So you have to expand that all the way out. So you have to do a 3p x, 3py, 3pz, and then 2 3ds. Okay? But that's the only expanded one I believe that I'm making you do. So.
Wait, do we gotta draw a picture or is it?
No, I'm drawing out the picture to just illustrate why we're doing that.
3s.
So 3s would stay together again. So you need to expand. You need to expand what I'm underlining right now. Those things need to be expanded out.
What would B be? It would be X.
You're going to have to look in the reading. Like there's an xy, there's a yz, there's a zx, there's a z squared. You're not needing to know that, but except to have reference. Okay? So, we don't have anything due today, do we? I think we're all good? Oh, the review is today. Okay. I saw a lot of people already handed in. So get that in at some point, please. If you want to hand it in now and you don't want to walk back to the resource and you have it done, you can put it on the front table.
Thank you. Wow, what a champ.
I love you all.